Morning. Your I can statement for today is I can subtract mixed numbers. So it's very, very similar to adding mixed numbers. There is one or two extra steps that you may need to take when you're subtracting mixed numbers, but it will look very similar to when we learned how to add mixed numbers. So your sample problem is today. A golf ball measures about 1 2/3 inches across the center. What is the difference between the distance across the center of the hole and the golf ball? So using our cubing strategy, we're going to circle any key numbers. So we have 1 2/3. And as we know, some of our key numbers may not always be right in the written problem. So I'm going to circle this key number over here. I'm going to underline the question. Whoa. That's not going to work either. We'll try this one. What is the difference between the distance across the center of the hole and the golf ball? Going to box any key numbers or keywords, boxing keywords. So inches, difference, eliminate anything I don't need, a golf ball, and I'm going to solve now. So I boxed the word difference, and when we see the word difference, we should automatically think that a difference is the answer to a subtraction problem. Difference literally means the answer to a subtraction problem. So if they're asking us what is the difference, that means I'm going to have to subtract something, right? So it's asking me to subtract the distance across the center of the hole, which is 4 1/4 inches. 4 1/4 inches. Minus 1 2/3 inches, which is the distance across the ball itself. So it's asking us to subtract those two numbers and find the difference between the two. So just like in adding mixed numbers, we need to find equivalent fractions as our first step. So we know we can leave our whole numbers the same, so I'm going to leave 4 and 1 out of this problem and just take my fractions to find equivalent fractions. So I have 1/4 here and 2/3 here. And again, there's multiple ways to find a common denominator. You can use your LCM, you can multiply across, you can look for factors. It's up to you. I'm going to choose to look for factors or find my LCM, and I notice that 4 and 3 have something in common. They're both a factor of 12. So in order to get 12 in the denominator here, I'm going to multiply 4 by 3. Okay, and what I do to my denominator, I need to do to my numerator. 3 times 1 is 3, and 4 times 3 is 12. So my new equivalent fraction for 1/4 would be 3/12. I need to do that for this fraction as well, and in order to get 12 in my denominator here so that they have a common denominator, I need to multiply this by 4. And what I do to my denominator, I also have to do to my numerator, so 4 times 3 is 12. And 4 times 2 is 8. So my new equivalent fraction would be 8/12. So I'm going to rewrite those fractions down here. So I have 4 and 3/12 now. 3/12. That's my new equivalent fraction. Minus 1 from my original problem. 1 and 8/12. Okay. So you'll notice that you can subtract 4 minus 1 very easily. 4 minus 1 is 3. However, when you try to subtract 3/12 minus 8/12, you cannot do that because 3 is smaller than 8. So here we have a problem. I can't subtract 3 minus 8. So what I need to do then is kind of do the reverse of adding mixed numbers. And you'll see what I mean in 1 second. Excuse me. So I'm going to leave my 1 and 8/12 alone because 8 is the bigger numerator here. The 3 in this numerator is what I really need to change or make bigger so that I can subtract easier. So what I'm going to do is take this 4, this whole number, and take one whole out of it, okay? So I'm going to take a whole out of it. I'm going to subtract 1, and that's going to become 3. Pretty self-explanatory. I'm taking one whole away from my 4, and it becomes 3. The question becomes, well, what do I do with this one whole? Well, we know that this one whole, since our common denominator is 12, we know that this one whole is also equal to 12 over 12. Okay? So I took one whole away from 4, made it a 3, and I know that this one whole is equal to 12 over 12. I'm going to put this 12 over 12 into my fraction that already exists. So I'm going to add 12 over 12 to this fraction. 12 plus 3 is 15, and we leave our denominator alone. And now I have 3 and 15/12. Yes, this is an improper fraction, but that's okay because we need to have a bigger number in order to subtract. So I'm going to write the rest of my problem here. And now I have 3 and 15/12 minus 1 and 8/12. And now I can solve like normal. So I'm going to subtract my whole numbers first. 3 minus 1 is 2. 15 minus 8 is what you need to solve next. Remember that your denominator stays the same, so the 12 should be there. And 15 minus 8 is 7. So your final answer would be 2 and 7/12. Okay? The reason I had to switch, remember, the reason I had to convert this fraction into a mixed number with an improper fraction was because my numerator was smaller than this numerator. So I had to convert this fraction by taking a whole out of the whole number, converting it to 12 over 12, and adding it to my fraction that was already here.